Peter and Stella compare colours they like and do not like. Here is a sorting diagram that shows their results. Write 2 colours that Stella likes but Peter does not like. So Stella likes is in this row here, and Peter does not like is this column here. So that means the 2 colours are white and orange. Their colours, if we go across, we can see that Stella likes, but if we go up, we can see that Peter does not like. Now, Peter likes the colour blue, but Stella does not. Write blue in the correct place on the sorting diagram. So we're told that Peter likes the colour blue, so it will be in this column here. But Stella does not like the colour blue, so it will need to be in this row. So that means blue needs to be written in this section to show that Peter likes the colour, but Stella does not. Here are 3-digit cards. We have 5, 6 and 7, and we need to use each card once to make these statements correct. So 46 is less than what number? Well, here we could use any card because 46 is less than 52, less than 62 and less than 72. But because we can use each card only once, it's best to come back to this question because we could solve the other questions and then see what card is left. So let's look here. We have 56 is greater than what number? Well, the only digit that works here is the 5, because 56 is greater than 50, but it's not greater than 60 or greater than 70. So here, the only card that works is the 5. And now, 76 is less than what number? Well, here, the only card that works is the 7. 76 is less than 77, but it's not less than 57 or 67, so we need to use the 7 as our tens digit. So that means the card we have left is the 6, and because we can use each card only once, we need to use the 6 here. Now the 5 and the 7 would still work, but because we need to use the 5 here, and we need to use the 7 here, that means the 6 must be used in this question. So 46 is less than 62. The number 20 goes in 2 of the squares of this multiplication grid. Tick the 2 squares where 20 goes. So we need to think what times what is 20. Well, 5 times 4 is 20, so we can tick this square because that shows 5 if we go to the left, times 4 if we go up, and 5 times 4 is 20. And we can also tick this square, because if 5 times 4 is 20, then 4 times 5 is 20 as well. Rosie collects data about birds visiting a bird table. Here are her results. Rosie saw 20 birds altogether. What fraction of the birds were blackbirds? So here we have a tally chart, and if we find blackbirds, we can see that we have 5 lines. So that means she saw 5 blackbirds, and she saw 20 birds altogether. So remember, with fractions, the numerator or top number is how many we have, and the denominator is how many there are altogether. So because 5 of the 20 birds were blackbirds, our fraction can be written 5 over 20. Here are 3 signs. We have equals, less than, and greater than. Write in the signs to make these correct. So first we need to compare 100 and 10 times 10. Now 10 times 10 is 100, so we need an equal sign here. And now we need to compare 100 and 15 times 5. So let's work out 15 times 5. We can use short multiplication and that gives us 75. So 100 is greater than 75, so greater than 15 times 5. And the way to remember that this symbol here means greater than is to imagine that it's a mouth of a crocodile snapping at the larger number. Or we could think this sign looks a bit like an arrow and the arrow always points to the smaller number or the smaller value. And now we have 120 times 6. So we know that 2 times 6 is 12, so 20 times 6 is 120, because if we have an end zero in a multiplication question, we need an end zero in our answer. So 100 is less than 20 times 6, because 100 is less than 120. Round each number to its nearest 10. Draw arrows. So 53 to the nearest 10 is 50. That's because to round to the nearest 10, we can find the tens digit and look at the ones. If it's 4 or less, we round down, and that means the tens digit stays the same. So this 5 stays a 5, and the ones digit turns into a 0, so that's why 53 rounds to 50. Notice 53 is between 50 and 60, but it's closer to 50, so that's why it rounds to 50. Now we have 46. We can find our tens, look at our ones, and if the digit is 5 or more, we round up. So when we round up, our tens digit increases by 1, so this 4 becomes a 5, which means 46 will round to 50 as well. It's between 40 and 50, but it's closer to 50, so that's what it rounds to. Now for 38, we can find our tens, look at our ones, and because it's 5 or more, we're rounding up, so the 3 becomes a 4, and that means 38 rounds to 40. And for 57, again we have 7 in our ones, and if it's more than 5, we round up. So the 5 becomes a 6, so 57 rounds to 60. It's closer to 60 than it is to 50, so we round up. And finally, we have 62. If the ones digit is 4 or less, we round down, and when we round down, our tens digit stays the same. So this 6 will stay a 6, meaning that 62 rounds to 60 as well. Raj thinks of a number. He says, if I subtract 14 from it, I get 29. What is Raj's number? So we know that if we take Raj's number and subtract 14, we get 29. So how can we know the original number? Well, with missing number subtractions, we can read them backwards as addition problems. So to work out this missing number, to work out the number that Raj thinks of, we can add 29 and 14. And 29 plus 14 is 43. So that means that Raj's number is 43. Because if we take 43 and subtract 14, we get 29. Write the missing numbers in the boxes. So we can see that we have a number line for decimals. And because to get from one of these thick lines to the next, we have 10 lines, that means each of these little lines in between must be tenths. So because we have 2.5 here, that means the whole number here must be 2, and the whole number here must be 3. But we can write 2 as 2.0 and 3 as 3.0, because if we have 0.0 on the end of a number, we have a whole number. 2.0 is the same as 2, because all this 0 tells us is that we just have the number 2, we don't have any extra tenths. So that means this number here is 3/10 after 2.5, so that will be 2.8. And then this number here is 1/10 before 2.0, so that will be 1.9. Notice 19 is the number before 20, so on a number line with tenths, 1.9 will be the number before 2, because 2 is the same as 2.0.